define the domain. So we have a rational function, f of x equals 2x over x plus 1. And what we're going to do is find or state the domain. The domain is the x values. And on a rational function, the concept that we're going to be using is that we can't divide by 0. Division by 0 is undefined. So I cannot have a 0 underneath this fraction. Anytime I had 0, it would make the whole thing undefined. So that's the only value for x that we can't have. So we take a look at this right here, and we say that value, that whole value, cannot be 0. So if I have x plus 1 cannot be 0, and I solve that, I have x cannot be negative 1. And that's the domain of this rational function. You can either leave it like that, and it's okay, it's sufficient to say what it cannot be, or you can change it to say what x can be. So if it can be everything else, we'll write that in interval notation as follows. So it can be negative infinity all the way up to negative 1, and then we exclude negative 1 by using the open parentheses there, and then jump over it and pick it up again at negative 1 to infinity. So let's practice this concept with another problem. The next problem we're going to do is f of x is equal to x squared over x squared minus 16. Don't be tempted to try to do something funny with those x squareds. You can't cancel those. But what you can do is factor the bottom. So, So we'll factor the denominator. And what we get is f of x is equal to x squared over x minus 4, x plus 4. That's because the difference of squares factors. So following the last example, we know that this whole value right here cannot be 0. So when I rewrite it here, this is the not equal to that I'm solving. X plus 4, x minus 4 cannot be 0. Zero product property tells us if one factor or the other is 0, then the product will be 0. So if this factor is 0, the whole thing would be 0. So we're not allowed to have x minus 4 as 0. That means x cannot be 4. Or if this factor is 0, then the whole product would be 0. So the two values I'm not allowed to have in this domain are negative 4 and positive 4. And here's how you write that in interval notation. You come up from negative infinity, and you're going to jump over this negative 4, and then you're going to jump over the 4. So it is sufficient to say either what x can be or what x can't be. Both are okay for stating the domain. So this one right here, this is stating what x can't be, and this way is stating what x can be. So it's everything except negative 4 and 4. But this sort of can be confusing because that looks like, oh, that's the values that it is. No, that's what it isn't.